this is our last example from section 4.3 day 1, and we're going to be taking a look at some special types of trig ratios or special types of angles that we're going to be using, and these are called the quadrantal angles. Now, the name actually is a little ironic because these quadrantal angles are the ones that don't have a quadrant. So these are the ones that are going to appear on just directly on the axis for each one. So there's one here, there's one here, here, and here. Now, if we're talking about this in terms of degree measures, that would mean that this is really 0 degrees right here. This is 90. This is 180 and 270, and then by the time we get back around, that's 360 is the same as 0. So we're going to be looking at these different points. Now, one thing I want you to realize about these different points is that if we're on the axis, as you can see, this point is right on the axis, for starters with 0 degrees. Now, if we were to go over and make a point out of this one, so an xy point, one thing that we could know for sure about this point, since it's on the x-axis, is that the y value is equal to 0. Now, the x value could change a little bit. The x value can be basically whatever you want it, but we want to make this as simple as possible, and a very easy number to work with, if there is a number, is 1. So that's going to be at the point 1, 0. And like that on these other ones, the other points here can be labeled as, this one's 0, 1, and then this one is negative 1, 0, and this one is 0, negative 1. So we just are labeling all the different points here so that we know what we can work with when we eventually get there. Now, those are the x's and y's. As we were dealing with our new definitions of sine, cosine, and tangent, we were talking about x's, y's, r's, and these would be the x's and y's. Now, the r is basically how far are you from the origin out to that point, the terminal side of the angle. The way that we've made all of these points is kind of convenient because we can say r is equal to 1. And remember that it's always going to be positive. R is positive every single time. So we're just going to have that all of these r is equal to 1. All right, that kind of just lays all the groundwork. That lays out everything so that we can now actually find the sine, cosine, and tangent. Can you do this on your calculator? The answer is yes. You could punch this in. As long as you're in the correct mode, you would be able to do this on your calculator. So if I were to come here and make sure I have my mode, okay, the first one's 90 degrees, and so I've got degree mode on my calculator. I could punch in, for instance, the sine of 90 degrees, and I could get an answer for it. So it's just 1. Or I could do the cosine of 90 degrees and get 0. All right, so this is available on your calculator, but I want you to also understand how this is calculated based on our circle here. So let's talk about let's do sine, cosine, and tangent for each. We don't necessarily need to do the other ones. We'll just keep it as simple as possible with that. So let's start with 90. We already got a little bit of an insight what the 90 ones are going to be. But sine of 90 degrees. Now remember that sine is the same thing as y over r. So we look at 90 degrees, we locate it on our grid here, and it says 90 degrees. We have the point 0, 1. Well, if this is y over r, y in this case is 1, r is 1. So the sine is just going to be 1 over 1, which simplifies to 1. And that's where the calculator was getting that information. All right, cosine in this case, cosine of 90 degrees. Cosine is x over r, which in this case is 0 over 1, which simplifies to, well, if you're not sure, punch it in your calculator, but that does simplify to 0. So we've got 1 for sine, we've got 0 for cosine, and now tangent in this one. And the nice thing about these problems is that you can always check your work. That's one convenient thing about the quadrantal angles like this. And the tangent is going to be y over x, or opposite over adjacent. And in this case, y is 1, x is 0. Okay, that's an interesting one there. We know, though, that anything that's divided by 0 is considered undefined. So just keep in mind that that is a possibility. That will happen from time to time here, where you have undefined for your ratio. So we've got those for our 90 degrees. Next up is 4 pi. Might need a little bit of space to do this, but 4 pi, negative 4 pi. Keep in mind that this is not an angle right now that we can identify on this circle. This is weird. So remembering that 2 pi is one full turn around counterclockwise, negative 4 pi is actually going to be going clockwise. If we go one full time around, that's 2 pi, or negative 2 pi. And then if we go another full 2 pi around, that's going to be negative 4 pi. So negative 4 pi is going to be at this spot right here. So that's something that we need to look at when we're computing sine, cosine, and tangent for this one. So sine of negative 4 pi, y over r, so that's 0 over 1. Reduces down to 0. Cosine of negative 4 pi, x over r. X is 1 in this case, r is 1, and so that's 1 over 1. That's equal to 1. And then finally here, tangent of negative 4 pi. Tangent is y over x. So that is 0 over 1 in this case, and that is 0. One thing that you will notice about all these different quadrantal angles is that you'll either get a 0, a 1, a negative 1, or an undefined. Those are really the only options that you'll have for these. Last one is 3 pi, sine, cosine, and tangent of 3 pi. Now, when you're working on these and you're doing them in your assignment, I would like you to say what they're equal to. Go 0 over 1 or 1 over 1. I would like you to write that out. That shows me what you're doing, how you're finding those different things. That gives me a little bit of information, especially when it comes to test time if you're doing a problem like this, which you will. 3 pi, though. 3 pi is counterclockwise, so I go 2 pi, and then one more makes 3 pi. So 3 pi is going to be at this spot right here. It's going to be at the 180 degree angle with x is negative 1 and y is 0. All right, so sine is y over r. That's going to be that's going to be 0 over 1 because the radius, like always, is 1. So that's 0. Cosine of 3 pi is going to be x over r, so that's negative 1 over 1. Reduces to negative 1. And then finally, tangent is y over x. So that in this case is 0 over negative 1, which simplifies to 0. So again, we have that it's either a 0, it's a 1, it's a negative 1, or it's an undefined. And that's a lot of stuff there. So hopefully that makes sense. But the quadrantal angles, they're always going to be right on the axis, which is ironic that they're called that because they're actually not in a quadrant.